Nucleotide excision repair is a type of DNA repair mechanism to remove damaged DNA that is caused by exogenous agents such as chemicals, UV light, or ionizing radiation. One major type of damage to DNA caused by radiation includes thymine dimers. The damaged base, along with the healthy strand, is removed and the gap is refilled with correct nucleotides.
A complex is formed with two UVRA subunits and two UVRB subunits. ATP hydrolysis promotes dimer formation by UVRA. UVRA and UVRB complex scans the DNA to identify a distortion. UVRA will then detect the distortion. When the distortion is found, UVRA exits the complex when the UVRB dimer remains and melts DNA locally around the distortion. UVRB dimer recruits UVRC and forms a complex, while one UVRB molecule from the complex exits. UVRC creates two incisions, one located 4 to 5 nucleotides 3' to the lesion and the other located 8 nucleotides 5' to the lesion. This cleavage creates a 12 to 13 residue-long DNA strand that contains the distortion. UVRD then removes UVRC and the lesion-containing strand and forms a 12 to 13 long nucleotide gap. When the cleaved DNA is being unwound, ADP is then released. DNA polymerase I fills in the gap and DNA ligase seals it, completing nucleotide excision repair.